In this video, we will try to answer this simple question: how would you remove the discontinuity of the function g of x, defined as follows: g of x is 4x cubed, plus 10x squared, minus 2x, plus 12, over negative x minus 3. It is clear that g of x is a rational function. Moreover, we know from a classical theorem that all rational functions are continuous in their domains of definition. Therefore, the function g of x is continuous in its domain of definition. Consequently, the function g of x is continuous at all points except points where the denominator is equal to 0. So we first have to identify points where the denominator of g of x is equal to 0. We need to solve the equation negative x minus 3 is equal to 0. We obviously see that the only solution of this equation is when x equals negative 3. Therefore, this means that the function g of x is discontinuous at x equals negative 3. The main aim here is to determine ways to remove the discontinuity of g of x at the point x equals negative 3. From the definition of continuity that the function g of x is continuous at x equals c if and only if the limit of g of x as x approaches c is equal to g of c. In order to remove the discontinuity at x equals negative 3, we need to find the limit of the function as x approaches negative 3. If the limit exists, then we set g of negative 3 equal to the limit of the function as x approaches negative 3. Therefore we will start by computing the limit of g of x as x approaches negative 3. Let us compute the limit as x goes to negative 3 of the fraction 4x cubed, plus 10x squared, minus 2x, plus 12, over the polynomial negative x minus 3. Let's see what happens when we directly compute the value of the fraction when x is equal to negative 3. After computing the value of the fraction at the point negative 3, we have minus 108, plus 90, plus 6, plus 12, over 3 minus 3, which equals 0 over 0. We have an indeterminate form of the type 0 over 0. As a result, we have to factorize the whole fraction in order to simplify the common factor. This occasionally happens when the quantity x plus 3 is a common factor of both the numerator and the denominator. The polynomial 4x cubed, plus 10x squared, minus 2x, plus 12 is divisible by x, plus 3, since they have a common root, minus 3. When we divide 4x cubed, plus 10x squared, minus 2x, plus 12 by x, plus 3, we get 4x squared, minus 2x, plus 4. Therefore, for x cubed, plus 10x squared, minus 2x, plus 12 can be written as the product of x, plus 3 and 4x squared, minus 2x, plus 4. We notice that the numerator can be factorized as the polynomial x, plus 3, times the polynomial for x squared minus 2x, plus 4. And the denominator can be factorized as the polynomial x, plus 3, times the polynomial minus 1. The common factor in both expressions that should be simplified is x, plus 3. By replacing negative 3 in this new function, we find that the limit is minus 46. The limit of the function g of x as x approaches minus 3 is minus 46. We just need to set g of negative 3 equal to minus 46. Therefore, the function g of x is continuous at x equals minus 3. The new continuous extension of g is as follows: g of x is 4x cubed, plus 10x squared, minus 2x, plus 12 over negative x minus 3 for x not equal to negative 3, and g of negative 3 is minus 46. Thanks for watching the video. Please like the video and subscribe to our channel. Thanks.